Now we are going to study about the types of chemical reaction. In this chapter, we have to study about different types of chemical reaction. They are, first one is combination reaction. Combination. Second one is decomposition reaction. Third one is displacement reaction. And the fourth one is double displacement reaction. And the last one we have to study this year is oxidation and reduction reaction. Now first let us study about the combination reaction. What is combination reaction? Combination means combining, joining. When two or more reactants, the reactants may be elements or it may be compounds. When the two or more reactants or substances join together and produce a single product, then such a reaction is known as combination reaction. In combination reaction, the chemicals are combining. Okay, when the chemicals are combined and form a single product, such a reaction is called combination reaction. Say for example, see when calcium oxide CaO is calcium oxide or it is called quicklime. When reacts with water, when it is mixed with water, H2O, calcium oxide, when mixed with water, so CaO plus H2O, what happens? Both combine together, both join together to produce CaOH twice. CaOH twice with the release of energy, with the release of heat energy. See here, calcium oxide, CaO, okay, CaO, Ca1O, H2, and another O here, both combine together. So, when the reactants combine together to produce a single product, then such chemical reaction is known as combination reaction. Another simple example, see carbon, carbon is coal. When coal is burned with oxygen, Ca plus O2. Okay, when carbon burned with oxygen, we will get carbon dioxide. Okay, carbon dioxide gas will come out along with the release of energy, heat energy. So this is another examples for combination reaction. Okay, so what do you mean by combination reaction? A chemical reaction in which reactants combine together to form a single product. Such a reaction is known as combination reaction, or we can say that chemical combination. Or the another simple example for combination reaction is the formation of water by combination of hydrogen and oxygen. See, when hydrogen, H2, when hydrogen combined with oxygen, H2 plus O2, when hydrogen combined with oxygen, you will be getting water, that is H2O. Okay, one product is forming. See, we have to balance this equation. See here, 2 oxygen, here only 1 oxygen. So how we can make oxygen 2? See, simply put 2 here. So 2 oxygen, 2 2s are 4 hydrogen. Therefore, how we can balance it? 2 2s are 4, but here only hydrogen 2. So put a 2 here. Now the equation is balanced. So see here, the formation of water. Water is a single product which is formed by the combination of hydrogen and oxygen. So two substances, two reactants join to form a single product. Therefore, this is another example for chemical combination. So the first reaction that we studied was calcium oxide. Calcium oxide is known as quicklime. When mixed with water, H2O, CaO plus H2O. Okay, two reactants. One is quicklime, calcium oxide, and another one is water. They joined together, combined together, and we got calcium hydroxide. Calcium hydroxide is known as slaked lime. Have you seen slaked lime or calcium hydroxide? See, calcium hydroxide or slaked lime is nothing but the thing which you are using for whitewashing. Okay, slaked lime or calcium hydroxide is the chemical substance which is used for whitewashing the walls. You know, while we whitewashing, the white color may not be that much bright. But after 1 or 2 days of whitewashing, the washed area will be very, very bright. You know the reason? This kind of questions will be asked for your public examination. Why the brightness of whitewashed wall increases after 2 or 3 days? The slaked lime or the calcium hydroxide which we used for whitewashing reacts with carbon dioxide present in the air. Okay, see, slaked lime, CaOH twice. This is slaked lime. Okay, slaked lime. Slaked lime means calcium hydroxide. The calcium hydroxide or slaked lime reacts with carbon dioxide. Reacts with carbon dioxide present in the atmosphere, and these two join together to produce calcium carbonate. Okay, calcium carbonate. See, the chalk piece is calcium carbonate. The marble is also calcium carbonate. The calcium carbonate, you know, is very bright white in color. Okay, very white in color with the release of water vapor. Okay, so here you see the calcium carbonate is formed within 1 or 2 days. The calcium carbonate is formed within 1 or 2 days. How? The slaked lime that we applied on the wall reacts with the carbon dioxide present in the air to produce calcium carbonate. That's why the wall become bright after 2 or 3 days. Are you clear? So such kind of question, tricky questions may be asked for your board examination. Why the whitewashed area become white, very bright after 2 or 3 days? You have to write. See, the slaked lime or the calcium hydroxide that we used for whitewashing reacts with carbon dioxide present in the atmosphere and it changes to calcium carbonate. That makes the wall brighter. The first reaction, that is the reaction between quicklime, calcium oxide with water, I told you that is chemical combination reaction, because two substances joined to produce a single product. So of course this is a chemical combination reaction. But you have to see, in this particular reaction, along with calcium hydroxide, slaked lime, heat is also released. Any reaction in which the heat energy or energy is released out is known as exothermic reaction. The reaction in which heat energy is releasing out is known as exothermic reaction. Okay, so what do you mean by exothermic reaction? Exothermic reaction is a chemical reaction in which heat energy is evolving out or the heat energy is coming out. Exo means towards outside. Thermic means heat. So a chemical reaction in which heat energy is coming out, released out, evolved out is known as exothermic reaction. Therefore, the reaction between quicklime with water is also an example for exothermic reaction. Another example I will tell you, burning of natural gas. See, natural gas is nothing but methane, CH4. Okay, natural gas consists of methane, CH4. When methane or the natural gas is burned, CH4 is burned. See, for burning we know that oxygen is necessary. So when methane is burned in presence of oxygen, see, it is producing carbon dioxide plus water vapor along with the release of heat energy. Therefore, burning of methane is also, or burning of natural gas is also an example for exothermic reaction. What do you mean by exothermic reaction? Exothermic reaction is a chemical reaction in which heat energy is evolved out. Example, the first reaction between calcium oxide and water to form calcium hydroxide, burning of natural gas, that is methane, and another biochemical reaction that is taking place in our body is also an example for exothermic reaction. Can you tell me? See, respiration. See, respiration is another example for exothermic reaction. What happens during respiration, you see? Respiration, see, after our digestion, if you say, for example, carbohydrate. When carbohydrate is digested, glucose is formed, C6H12O6. This is glucose. Okay. After digestion, this glucose goes to your cell, and from cell, the glucose is oxidized. Okay. When you inhale the oxygen, the glucose gets oxidized to produce carbon dioxide. Okay, the carbon dioxide we are giving out through our nostril. Okay, the carbon dioxide you are giving out through your nostril is formed as a result of the oxidation of glucose plus water vapor. When you exhale, in front of the mirror, you can see the water vapor. The gas coming out is carbon dioxide, and you can feel a warmth. Okay, that means what is coming out? Heat is coming out. Okay, heat energy is coming out. Therefore, respiration is also an example for, okay, respiration. Respiration is also an example for exothermic reaction. Okay, a reaction in which heat energy is coming out, evolved out, is called exothermic reaction. The biochemical process, that is respiration, is also an example for exothermic reaction. Here C6H12O6, that is glucose, when burnt with oxygen or oxidized, carbon dioxide and water are produced along with the release of heat. Now let us balance and see this equation. See here, there are 6 carbon atoms in the left hand side, in the product side, but here only 1 carbon is there. There is only 1 carbon. So it is imbalanced. Here only 2 hydrogen this side, right hand side. But see here 12 hydrogen are there. So let us begin with hydrogen. Okay, because that is in more. So we can start balancing by looking into an atom having more number. Now here 12 hydrogen, so we have to make it into 12. What shall we do? Put a 6 here. When you put a 6 here, 6 2s are 12. Here also 12. And next you see here carbon 6. 6 carbon are there, but here only 1 carbon. So let us put a 6 here. So carbon is 6, carbon is 6, hydrogen is 12, this side also hydrogen is 12. Now let us see about the number of oxygen atom. Whether the number of oxygen atom in the left hand side is equal to the number of oxygen atom present in the right hand side. See here, how many oxygen are there in the left hand side? You see, in the left hand side the number of oxygen is equal to 6 plus 2, 8. But see here, here oxygen 2. So 2 into 6. 2 6 are 12. Okay, 12 plus 6. Here oxygen is 18 in number. Okay, right hand side 18 oxygen are there, whereas in the left hand side only 8 oxygen are there. How we can solve this issue? See, just put a 6 here. 6. When you put 6 here, 6 2s are 12, 12 plus 6, 18. Now the oxygen in the left hand side is 18. Here also oxygen is 18. In the right hand side, left hand side carbon is 6. Here also 6. Here hydrogen is 12. Here also 12. Now the equation is balanced. Okay. So respiration is also an example for exothermic reaction. Another exothermic reaction is that is formation of compost. Okay, when the waste are made into compost, heat energy is released out. Okay, that is decaying of waste material are also example for exothermic reaction. So what do you mean by exothermic reaction? Any chemical reaction in which heat energy is evolved out is called exothermic reaction. Similarly, there is another reaction, endothermic reaction. Endothermic means, endo means towards inside. A chemical reaction in which heat energy is absorbed. When the heat energy is absorbed, when the heat energy is taken in, such a reaction is known as endothermic reaction. Okay, say for example photosynthesis. Photosynthesis, absorbing heat energy and producing glucose. So photosynthesis is endothermic, whereas respiration is exothermic. So what do you mean by endothermic reaction? A chemical reaction in which heat energy is absorbed is called endothermic reaction. And a reaction in which heat energy is released out is known as exothermic reaction. Another chemical reaction that we studied in the first part, burning of magnesium ribbon. Burning of magnesium ribbon is also a combination reaction. Okay, during burning of magnesium ribbon, see, we burned magnesium, that is Mg. For burning, oxygen is needed. Okay, magnesium plus oxygen gives magnesium oxide. Okay, two reactants combine to produce a single product. Therefore, magnesium oxide formation is also an example for combination reaction. How we can balance this? Here 2 oxygen. Yes, so put 2 here and here 2 Mg. Put a number 2 here. Now the equation is balanced. In your textbook there is a question. Before we burning the magnesium ribbon, we have to clean it thoroughly. Why? See, magnesium is one of the active metal. When we simply keep it, on the surface of magnesium, some oxides are formed. When these oxides are there, magnesium reacts with atmospheric oxygen and form a layer of oxide on its surface. When this oxide layer is there on its surface, it will not catch fire easily. Therefore, we have to clean the magnesium ribbon thoroughly by rubbing. Okay, with sandpaper we can rub thoroughly. So the oxide layer will be removed out. And very bright metal you can see, magnesium metal. And after that, if you burn it, it will immediately burn with a bright flame. So there is a question in your textbook. Why should a magnesium ribbon be cleaned before burning in air? Okay, why should we clean the magnesium ribbon before burning in air? Why? Magnesium is an active metal. It's a reactive metal. When magnesium is kept outside, it reacts with air and form a layer of oxide on its surface. When the oxide layer is there, it will not support burning immediately. Therefore, the oxide layer need to be cleaned and removed before burning in air so that it will catch fire easily. Okay.